Hey, this is Mr. Ward, and I'm going to do now a video on graphing point slope form equations. And when we're graphing by hand, instead of letting a Desmos utility do it for us, and you need to know how to do this yourself, it helps to have 2 points. Now, the point slope form is very useful in that it gives us 1 point and a slope. And with 1 point and a slope, you can map another point using the slope. So we can plot the first point and then map for another point using the vertical and horizontal change that the slope tells us to do. So the first trick is figuring out what is the point. So for this equation, y minus 3 equals negative 2 times x minus 1. The thing that is the point, since the equation is structured as y minus a known y value at a point that is on the line equals slope times x minus a known x value that is part of the same point that is on the line, we are given a point. So we're given a point that is going to be at an x value of 1, because this is x minus the x value, and a y value of 3, because this is y minus the known y value. So now I can plot a point. So let's go ahead and plot a point. I'm going to move the line over so it's out of the way. So let's grab this one, and we're going to go to 1, 3. So here's 1, and we go up to 3. And now I've plotted one of my points. Now we're going to use the slope, which is negative 2, to get a second point. Now, negative 2 is a whole number. It might be easier to work with it as negative 2 over 1. So now we can create another point. So I'm going to take the 1, 3, and I will add 1, because add 1 to x, because the denominator is the horizontal change in slope. That's the change of x. So 1 plus 1, which will equal 2 for the x part. And then for the numerator is going to, of course, be the vertical change. And I'm going to treat that negative as attached to the numerator for right now. So I can plot a second point by taking the y value and subtracting 2, which gets me a point at 2, 1. So I can take this other one, and drag it over to 2, 1. Now, you could also, there's no reason I had to do down 2 over 1. I could have done up 2 back 1, because that negative could have been attached to the denominator instead of the numerator. Because negative 2 over 1 is the same as 2 over negative 1. So now I'm going to say the x value is going to be 1 minus 1, because that's going to be a denominator change of minus 1. And then the y value is going to be 3 plus 2. Okay, and 3 plus 2 will be 5. And 1 minus 1 will be 0. Now, let's actually put this point there now. So 0, 5. And you might notice that we've just identified a y-intercept inadvertently, and that'll be convenient. But so now we have a point here. We have that point at 1, 3, and we also identified this point at 2, 1. And you could use these two that are right next to each other. I think it's often easier if you have the 2 points a little farther when you're trying to get a nice, tidy, straight line. So I'm going to do that. So I'm going to grab this, and I'm going to try and line this line up parallel with these 2 points, because once it's parallel, it's easier to move. And then I drag it over, and there you have it. Now, the other thing you could have done with this is, if you didn't want to do it mathematically over here, you could have just mapped it on the graph. A slope of negative 2 over 1 means you're going to go down 2 over 1, down 2 over 1. Every point on this graph has that relationship to other points, down 2 over 1. And down 2 over 1 could be scaled to be down 4 over 2, because negative 4 over 2 is the same as negative 2 over 1. And then you could go the other way, up 2 back 1, because positive 2 divided by negative 1 is the same as negative 2 divided by positive 1. Or up 4, back 2. Okay, and from here I could go down 8. Okay, down 8 over 4, because negative 8 over 4 is the same as negative 2 over 1. So there we have it. That we've graphed this equation. Now I'm going to go to the next one, which is a little different. We're going to have to figure out what the point is. So y plus 5 equals y plus 5 equals 5/4 times x plus 3. So what is a point that we can find on this? Well, so the equation is y minus a known y value, but this is y plus 5. And that is supposed to equal slope times x minus a known x value from the same point that is on the line. Well, here's how you deal with that. Y plus 5 is the same as y minus negative 5. And x plus 3 is the same as x minus negative 3. So we are going to have a point at negative 3, negative 5. So let's plot that first. Negative 3, negative 5. Now we have that point. So let's go ahead and grab one of these and move it to negative 3, negative 5. So negative 3, oops, now it's trying to stretch it. Let's try that again. Okay, grab it. So negative 3 and negative 5 will be here. Okay. So there we have that. It's not quite there, but let me get it nudged a little bit there. I think that's a little better. Maybe a little more. You don't have to be super perfectionist with this. At least for the test, I'll understand if you're slightly off. So now we've got to plot another point. So the slope is 5 over 4. So from here, one approach we could do is we could go vertical change is 5 because it's rise over run, vertical change over horizontal change. So you go up 5 and then count over to 4 so that we should have a point here at 1, 0. But let's confirm it mathematically. So what we're going to do is we're going to add the denominator to the x, and we'll add the numerator of the slope. We'll add the denominator of the slope, 4, to the x, because that's the horizontal change. So negative 3 plus 4. And then we will add the numerator, which is the vertical change, to the vertical component, which is negative 5. So negative 5 plus 5. And negative 5 plus 5 is nada. It's 0. And negative 3 plus 4 is 1. So in fact, yes, we would have another point right here at 1, 0. And then you could just move your line to go through those points. Let me grab it a little better. Okay. And just maneuver it around until you've got the line drawing through it. So on paper, you just get a straight edge. It's actually easier on paper than using this Google Draw. Just grab a straight edge. It could be a ruler. Doesn't have to be a ruler. It could be the edge of your notebook that I know you definitely are. If you aren't, you definitely should be taking notes in this math class to capture those aha moments and move them from your short-term memory into your long-term memory so they don't disappear later on. So here we go. Straight edge goes through 2 points. All you need is 2 points in order to get a line graphed. So you plot the 2 points and draw a line. I could have found other points. So 5 over 4 is the same as 10 over 8. So I could have also added 10 would be added to, that's the vertical component, and 8 would be added to the horizontal component. So I could take this negative 3, 5, and I could add 8. That's, oops, let me add 8. Let me also put parentheses around there so it's a proper point. That's the x component because 10 over 8 would mean a vertical change of 10 and a horizontal change of 8. So I add 8 to the x, and then the y part is negative 5. I would add 10. So now I'm going to have a point where the y value is 5 because negative 5 plus 10 is 5. And the x value would be 5 as well. And we can take a look at our line. Our line isn't quite drawn right. It should go through there. So having a third point is useful because the line definitely should go there. Now, if we look for the error, the error is that we're not quite, because this point isn't quite plotted on the grid, we're slightly off. And now we can adjust it. And now that line is a bit better. Maneuver it just a little bit more. Okay, so that's a little better. If it were being graphed precisely, it would go through -3, -5, 1, 0, and 5, 5. Those would all be points on the line. So it's a little bit of an art as well as a science there. Maybe that's a little better. All right, I'm going to stop sharing, and I hope that helped. So that was point slope form graphing. Use the fact that a point slope form gives you 1 point, and then use the slope to map a second point. A third point, as you can see, is useful because it can help us find errors in our graphing, like I just discovered.